welcome to this session. Thank you for joining us. So I'm Dhaval Thaker. I'm a senior manager at Verizon. I am engaged in the building microservice app platforms and also looking at how to build cloud-native apps. So in this presentation, I have with me Nick Bogdatov. He's also from Verizon. And then we have Mukesh, Gadiya from Pivotal, who's going to join in this talk. So what we're going to talk here is, how do you monitor and troubleshoot microservices in production? And the way we are approaching this is, so first, I'm going to talk briefly about, what our platform looks like and what is the importance of metrics for us in this environment. Nick is going to take a real issue which we faced in production a few months back, and then challenges he had to debug through that issue using our existing tool set. And then Mukesh is going to talk about, with the new version of PCF Metrics, how we could circumvent that, the whole debugging process, how we could make it a lot more efficient. So with that, so 2 years back, I was pulled into a meeting that we need to build a new application because at that time the services and platform were not that much of a buzzword. That we wanted to, Verizon wanted to build an application which is used for new network rollouts. And this application is going to be used for, for all the networks. So the last mile, the access network, metro network, as well as the backbone network. Now, typically, if until then, we had different monolithic apps which were purpose-built to do each of these functions. So there was an app which would just look at metro network and it would support, the provision function. And then there would be other app which would do the surveillance and so on. So the first challenge we had was how to bring all this together. And we knew that, since when you launch a new network, right, the network is always going to grow. And what that meant was the app has to be mission critical all the time, 24/7, 365 up, but at the same time, it has to scale with the business. Because if we cannot scale, business would suffer. So at that point, we looked at, what can we use or what are technologies outside? And of course, the first, no-brainer was services. And but then I have put few must-haves here, and by no means this is an exhaustive list. But over our 2 years journey, these are the few things which definitely helped us. And the very big one is the domain-driven design. And I can't stress enough how it helped us to stay sane through our application development. And primarily with the domain-driven design, the strict boundaries which you draw, and so that your code aligns with the business. And so it helped us two ways. Anytime we bring in new developers, they know exactly how the code is written, which domain is impacted. And second, it also gave us an isolation that if you want to, say, scale the build function, or if you want to scale the monitor function of a network, we have a domain which just addresses that. And with the domain-driven design boundaries so that you have services database logged into one domain, we can confidently make that change without impacting the other domains. And then, of course, there are the DevOps, the infrastructure automation, ability to scale, go to new markets, deploy new apps. All this is table stakes now. But the last piece is also important for us. So in Verizon, we pay a lot of importance on the metrics and on the surveillance and collection of data. And that also comes from like a best practice, because in a network, anytime a network goes, any component of a network goes down, whether it is a fiber cut or even it's a card failure, there's going to be significant impact to our infrastructure as well as to our customer. So it's very important that we pay attention to that. And in this, for us to build this new application, we wanted to make sure we bring those best practices in. And what that meant was we needed a solid foundation for capturing metrics and ability to get to the root cause, to be able to get to the triage as quickly as possible. One more thing, this wouldn't be complete if we say that, when we started building microservices, but then we realized, within a few months that alone is not going to cut it. What we really need is the cloud-native apps. And since we built this on Spring Boot, bringing in Spring Cloud and other components was, kind of piece of cake for us. So where we are now. So over the last 2 years, we grew significantly in terms of our service instances, in terms of our environments. There were multiple factors which drove it. One was that when our other IT peer teams looked at what we are doing, they wanted to join and they wanted to contribute to writing services, a refreshingly different model than trying to figure out working in a monolithic. And also with the business needs, we could keep up with the business needs. If there is a new launch in a new new region that requires to quickly spin up instances and deploy, all that was doable. So when we started on deploying our service on the Linux VMs. We were collecting matrices using, typical syslog and other utilities. And then around 2016 timeframe, we moved to on-prem PCF. So what that enabled us was to get even more metrics, right? And it made it easier, collecting the metrics and then analyzing them. But then with this scale, we also saw that we needed to put our own metrics collections, like whether it is even simple data exchange or making our custom metrics which drive our business, business logic. So at the end of it, we now have more data, and what our problem became is, if there is an issue in production, how do we quickly identify the issue, right? Because any impact would be felt across, different deployments. So talking about issue, we did run into an issue. And that's what Nick is going to talk through, how he went through debugging this issue using our existing tools.
Hello, everyone. My name is Nickolai Bogdatov. I'm a software developer in Verizon. And I'm going to talk about a real-life situation when under significant load, our application start crashing, and our monitoring tools caught that and notified us, and we all start looking into that. As you can see, even when we have multiple instances running in Cloud Foundry, our application keeps crashing. PCF does the good thing. Application starts up, but still crashing. So we have to figure out what's going on. So first stop was PCF Metrics and obviously logging. So you can see here that Cloud Foundry events show our multiple crashes. And what we observed here was that once application reaches certain memory limit under the load, it crashes and restarts. Meanwhile, it stopped processing our data. Now, but we still don't know why this is happening. We need to dig deeper and figure out what's the root cause. Existing PCF metrics at that time didn't provide us with the information what's going on inside of our JVM. So we need more detailed information. To do that, we created a project in JMeter to simulate the load and had to bind our applications to New Relic to give us more details. And of course, our first suspect is the memory leak. So what we did also was that using Cloud Foundry Java plugin, we grabbed some memory dumps, heap dumps, load them into Apache memory analyzer tool, trying to figure out where the leak is. But it didn't give us any significant insight. Everything looks fine. So now we went to New Relic statistics, and you can see here the heap usage, different JVM spaces. We kept looking, and looks like nothing was wrong. At least here, nothing shows up. So we look at different spaces. Again, not a clue. So now, let's talk about native memory. Maybe the issue is there. So what we did was we enabled native memory statistics, then plugged some scripts to monitor native memory, and again simulated the same load. And bingo, we found that under the load, we run out of native memory. So what we had to do was we had to increase our thread count. We had to decrease our thread stack. We had to bump up a little bit container memory. And of course, what's most important was we had to redistribute our memory, how it gets allocated. So lesson learned here is that with microservices, when application runs in a small JVM, in a small virtual machine with limited resources, if you misconfigure or you didn't pay enough attention to your memory settings or your disk settings, you run into problems much faster than it's on regular, let's say, big Linux box. So you have to pay attention here. And now everyone is happy. Our application runs. It doesn't crash. That's how it's supposed to be. Now, we got our resolution. We got to the root cause. But it took us quite some time. And why is that? We could make a shortcut. We might get to the native memory analysis much faster if, at that time, PCF Metrics would give us more details. And Mukesh is going to talk just about that, how and what PCF Metrics can do for us in those situations. Thank you.
Thank you, Nick. Thank you, Dhaval. Thank you, Nick, for setting up the stage really well. I have the first slide, which kind of summarizes the recap of what exactly you described. So I'm Mukesh, Gadiya. I'm the PM for PCF Metrics at Pivotal. Been at Pivotal for 26 months, and I've really enjoyed time so far. All right, so I know most of you have seen this slide many times. So the Pivotal mission is really transforming how the world builds software. And there are three components. There's more, but there are three major components of that. The leftmost is the Pivotal Cloud Foundry, Spring Boot at the middle, and then the Pivotal Labs at the rightmost. So it's like the technologies of Cloud Foundry and Spring Boot together with Pivotal Labs, like processes, pair programming, et cetera. Tracker, helps the world build software. So we took a clue. We said, what's a PCF Metrics mission? And to put it succinctly, it's transforming how the DevOps monitor Spring Boot apps. And there are 5 things associated with that. So the leftmost is the metrics, the logs, events, alerts, and tracing. All right, so let's look at more or less the scenario that Nick described. The app is crashing. You notice it. So how do you notice it? As Nick described, he noticed it in the Apps Manager, a PCF product. You could have other ways to notice it, which is you have a logging solution that's parsing logs and sending you messages. So one way or other, you notice it. So from there, you take the timestamp, take the app name, go to your metrics system, go to the exact timestamp, filter out all the other apps, and just focus on your own app. From there, you go to your logging system, carry on the same context, the narrow time window, the narrow, the app name, the metadata that you need to deep dive in the logs. Many times in a microservices architecture, then you go to a tracing solution. And again, carry on the same metadata on time and app name and foundation name, et cetera. And essentially, this is always a manual process where you have to change time, repeat, go through all these tools. And that's what happens. You spend hours, and it's a very painful process. So the summary is there are many tools for one specific problem that you're facing. And it's agonizing. And I've gone through it. What's worse is you don't have these tools set up all the time, always. You need someone else to set it up. You need configuration either in your code to set it up. They are complex products to use. There are 100 tabs in the monitoring product that I've seen. I don't know why, but there are. And last but not to forget, they're expensive. So what if your app crashing again? You get a link in Slack. It gets you to the view that has actuator metrics, application logs, application events specific to PCF, and any trace information that you would need. A very simple time toggle to repeat it, to go across different time window. You could save hours. And the story here is we are going towards a single pane of glass, making you happy. But the most important one is, as a developer on PCF, you don't have to do anything to set it up. It was out of the box. You don't need an agent in your code to have the monitoring and the metrics uncovered. The product is simplistic that my grandmother could use, and it's free. So PCF Metrics is, the way I like to put it is observability unified. And here's a screenshot of that. On the right top corner, you see the green thing. That's a time toggle. You can move it across the entire time window of 2 weeks. That's what we support. Just below, you have an ad chart. That ad chart allows you to add different metrics on the dashboard, including the Spring Boot actuator metrics. We have default metrics that you see on the screen, which are very specific to PCF. There is a toggle, again, on the right top corner that is application instances view. On the lower half are the logs. We allow the free text search, filtering, etc. So what are the components of observability? 5. Metrics, logs, events, alerts, and tracing. And our story is to unify them in one product so you don't have to hop around switching context in different tools, etc. So what sort of metrics do we provide? The first 2 are container and router, and these are very specific to PCF. Container metrics are the metrics emitted by Diego cells. Even if you are familiar with any APM tools, you won't get them because those are specific to PCF. The router is essentially the application latency plus any router latency in executing a request, which comes via router. The JVM, the URI, and custom metric are enabled by Spring Boot actuator metrics. The second is logs. Again, it's a simplistic log solution. This is not meant to have 100% functionality from Splunk, but it is meant to provide you with the basic things that you need to troubleshoot stuff. So free text search, histogram, order for newest and oldest, download logs to have analysis later on, and filter by key value. Events, again, specific to PCF apps. Like you see, there's app crash, which is the most popular one. Stage fail, which I'm seeing more usefulness from our customers, where a developer is pushing an app and there's a staging failure, and you can actually see it in the PCF metrics. All right, so this is the stuff that I'm really excited about. So all this time, the stuff that is there live does not have alerts, right? And we are actually actively building on this, available in Q1 2018. And we may have a release coming pretty soon on PWS, just to have, it's a slice bit of functionality, but I think the full-blown will be in Q1 2018. So what does this have? If you look at the last bit in the first row, /health, right? So /health is a Spring Boot endpoint that you can add on, databases or like health of database, health of external dependency, and we will be able to alert you if any of those elements in your health endpoint is not doing well. Again, same alerting on metrics and events. You can, for all the metrics that we support, including the system metrics, the Spring Boot actuator metrics, and app events, right there. You set a monitor, and then you'll be able to get an alert when the threshold is exceeded. There's also alert visualization on dashboard, and that's what you see on the left screen. And for now, we are limiting ourselves to webhook notification, but we're just starting. So this is my favorite, distributed tracing. If you have Spring Cloud Sleuth enabled in your applications, and your applications are going via GoRouter, then you don't have to do a thing to see this. And what is this? So on the left-hand side, I don't know if it's clear or not, but are the list of apps. On the right-hand side, in the top view, are the HTTP request per app and how long it took. And in this specific case, the money demo, the one that's green highlighted, has taken 10,000 seconds, 10,000 milliseconds, so 10 seconds. And what you see, again, you click on that, the big green line, and then you'll see the logs specifically for that request. So again, we're carrying the same story. It's not just the latency analysis, but also logs in tandem, right? One thing to mention, I've heard this many times that, hey, does this require Zipkin setup? No, it does not. So the way we do this is Spring Cloud Suite annotates logs with trace ID, span ID, and parent span ID, which is the whole tracing terminology, and that's how we actually drew these graphs and show these logs. So yeah, there's no Zipkin required. The future, you want to see it? Okay, the multidimensional metrics. I don't know how many of you saw the talk, Micrometer, working very closely with John Schneider on Micrometer stuff. Micrometer has multidimensional metric, that's the only type of metric it supports. So very soon we'll start supporting multidimensional metric. So apart from the Micrometer part, multidimensional metrics are a very powerful way, a powerful way of monitoring applications. So I'm super excited about that. The current view in PCF Metrics is always on single app, right? You come to this view knowing that this specific app has a problem. So the multi-apps health dashboard is a view level up where you see aggregation of apps and their individual aggregated health represented so that your NOC or AOC folks can know that, hey, in a platform I have these critical apps and these two apps seems unhealthy. Let me click on it and go to PCF Metrics. Services metrics. So apps, like most apps have a state, and that state is usually in data services. So having data services metrics in tandem, again, in correlation with application metrics is the services metrics. Multi-foundational view, I've had many conversations. Most of our customers have multi-foundations, like app deployed across multi-foundations for disaster recovery, for geo-proximity, for whole 9 yards. And so this is something we're still evaluating. Maybe there are different ways to solve it, but it's something that I'm definitely thinking of. PKS and Spring functions are there. We will see how PKS adoption goes. But if it goes, really fast, then we do have to think about supporting application monitoring on PKS and Spring functions. All right, so DevOps, you love code, the code that's on PCF, right? You're hugging. PCF Metrics is here's the Spring apps on the cloud, PCF. Help me run them well up there. I do not care how. All right. So one more thing before we wrap up. Independent of what product you're using for monitoring and troubleshooting, there are 4 golden performance signals for API for app that you should care about. This is coming straight from Google SRE book. If you haven't read it, you should. latency. This directly affects SLIs, service level indicators. Your users may not see like a lack of unavailability, but there will be degraded performance. You should always be caring for this. Traffic. So this is how much traffic my services are getting. If your services are, there's a baseline of traffic, and suddenly for some reason, if it drops, you should be monitoring that. Errors. This is a classic case of unavailability, crashing, and that's causing SLOs going down or SLAs. And saturation. And saturation, I have mixed feelings about this. Saturation is essentially resource consumption of the hardware in your app. So disk usage, CPU usage, memory usage. Sometimes these are leading indicators of performance problems in latency and traffic and errors. But I would say that the top three are the most important one. All right. So thank you very much. And check us out at metrics.run.pivotal.io. This is on PWS. You can check it out and give us feedback there. All right. Thank you.